there's room in here. Just enough for two in here.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard. Here we have a static problem that can be solved only using Newton's first law. We have an engine that has been hung from the ceiling and the wall, and we would like to calculate the magnitude of all these tension forces, T1, T2 and T3 in these chains. So essentially we have two bodies, the engine and then the ring that ties those chains together. So we need two free body diagrams that are key to solving any kind of mechanics problems. So in the free body diagram, the body itself is reduced to a single dot. So this is for the ring. So what kind of forces are acting on it? So it's being pulled to the left by T2, the tension from the chain 2, and then diagonally T3, and then also down by T1, because there's the engine hanging on the bottom. And usually in these kind of problems, we defined coordinate axes. So let's put x positive that way and y positive that way. And we have to divide our forces that are not aligned with these axes into the respective components. So here we have the horizontal component of T3 and here the vertical component. And we see from here that there's an angle of 60 degrees right there. So the same angle is of course here. Let's call that angle alpha, which is 60 degrees. So in that case, the vertical component must be T3 times sine A, and the horizontal one T3 cosine alpha, like this. So now our free body diagram is complete for the ring, and we can extract some equations from this. And now here comes the Newton's first law, which says the sum of all forces in both directions have to be zero because the system is not accelerating. So let's look at the x direction first. So in that direction, the forces must be zero. So what do we have? In x direction, we have positive force T3 times cosine A. The same as T2. What about in the vertical direction? Well, there we have, of course, had to be zero. So there we have T3 sine A equals whatever is pointing down, that's T1, like this. So we still have three unknowns here and only two equations, so there's something missing. And of course, it's the free body diagram for the engine. So for the engine, there are in fact only two forces, as we can see. The T1, the chain is pulling it up. So the chain is considered to be massless. So the tension is constant on the chain. So there's the tension 1 that is pulling down the ring is same as the one that is pulling up the engine. And then on the engine, it of course has the weight W down. And that's all for the engine. So here we simply get T1 equals weight. And that's the missing equation. That is the key to solving these ones as well. So we know T1 equals W. And we can put that in here. So T1 is W, so from there we get T3 equals W over sine alpha, which is W over sine of 60 degrees. It's about 1.16 W. W is the weight of the engine. And what else? T2 is same as T3 times cosine A, so 1.16 W times cosine, or 60, that's about 0.58 times the weight. So most of the weight is borne by the chain 3, followed by chain 1 and chain 2.